You can also, you can also change the geometry of these things. So like you can make a bar across here that has two of them on opposite ends. So they don't necessarily have to be in series. You can make them in parallel. Yeah, they're not rotating now. So I must have done something. Yeah, I guess because I put the fixed point down here. That must have done a better job there. It's interesting how the motion gets more wild the farther down you get. So you can make a 7-bob pendulum, and it's really going to go nuts down at the bottom. Let's save that as a triple pendulum. And let me show you one more. One more of my favorites is the cart pendulum problem. So this is, you have a pendulum here. It is attached to a cart that is free to move along the bar here. When you let this thing go, the pendulum is swinging back and forth, and some of that energy gets transferred to the cart. So the cart moves back and forth, but of course the cart is not going to move forward steadily because this thing is going to move, is going to make it, move in fits and spurts, basically. Let's actually move the whole thing, not like that. Let's grab, I guess I have to move it as a group. Let's grab the whole thing over here to give it a little more space to move. And I would like to look at a graph of the car's position versus time. Just the position of the velocity. All right, let's take a look what this does. Oh, I'll need to, let's increase the time span. There we go. And you see how its position is moving in these fits and spurts. I think that's, that should be a regular pattern for the velocity. If I look at velocity x. It's basically a sine wave that's been vertically shifted, which is what leads to that staircase effect in the position. So if I go backwards, let's start it over. Yeah, that's really cool. I'm losing a little bit of the energy here, it looks like, because I do have some friction going on there, probably in the axle and the wheels. But yeah, that's really neat. This is one of my favorite problems. And of course, you could modify this all kinds of ways, right? So you could attach a double pendulum to this contraption. You could make it a I do not want to do that. Oh well. You can make it a double pendulum, make it a spring pendulum, whatever you want to do. Let's actually just take this thing and glue it to the. Okay, it's staying put now. All right, that's fine. It's like I could take this thing, I could grab these objects, clone those. There we go. Get myself a double pendulum on here. Oops, that got itself axled down to the sky there. There we go. So what I'll do here is selection, move to the front, because I want that axle to pin down on the pendulum bob there. There we go. Now we've got our double pendulum attached to our cart. Let's move that over here. Now let's get, please, a plot of this thing's. Let's go ahead and make it the x velocity. There we go. Right, and release. Oh my, this is I don't know if this thing is actually making any net forward progress. I guess it is somewhat. Yeah, okay, I can tell because I can integrate the thing right away. I can tell it's moved forward about 0.9 meters so far. Yeah, there we go. It's moving forward now. Let's suppose I take this up this way. Whoosh. Yeah, that's really cool. So yeah, you can play around with this. You can do a lot of stuff. Literally, the sky is the limit on what you can do in this wonderful physics sandbox. So if this program is of interest to you, I know this is not strictly speaking computational physics. This is a simulation. It is computational physics in the sense that it is doing physics with a computer, but all the coding stuff is hidden behind a black box. But that's useful to our students because they need to start with that before they can get to the coding. So if this program's of interest to you, let me know in the comments below, and I might put together a formal tutorial series about this in the future. Thanks so much for watching. I will see you next time. Bye-bye.